Okay. So let me go over some of the join techniques. Do you have idea about the left semi, left out, left anti-join and all this stuff?
Yeah, I kind of have a vague idea on it, but I can just read up on that.
Okay, now let me show you then. Okay. So let me create these two tables. So these are some dummy data that I'm using. I've created the data frame out of the rows and the schema. Okay, so this is the DF1, and this is how it looks. It has the employee ID, salary, and designation. And then this is the DF2, where I have the corresponding employee ID, employee name, and the years of experience. Now, inner join, we know. Now coming to the left and the left semi, I'll show you the difference between them.
Okay.
So the column I'll be using is employee ID. So what's happening over here? So from the DF1, it's matching the ones from the DF2, and it is giving me everything over here. Okay. So these are the unmatched values. Okay. For 5, 6, 7s, there is no record in DF2, right? So this is left join. Now,
Okay.
now what if I want the left semi? Okay. So see what happens over here. So you see, this is just a portion of the DF1 only. Okay, we don't have the employee name and the years of experience, which is belong to the DF2. But even from the DF1, only the ones for which the matching record is present in DF2. So what semi does is basically it will match up the records, but it will only pick the ones from the left side only. So that is why it is known as the left semi. All right.
Mm.
Now let's see the left anti. It's the exact opposite. So now you will see only the unmatched records for which there is no data in DF2. Those are only giving me and only keeping the left side only. So this is left semi and left anti. Rest left joint, inner joint, right out. I mean full outer joint. Those are the same as in SQL. So I'm not
Mhm.
gonna go over those. So let me show you some more functions, especially the window functions. Okay. So what I'm gonna do, I'm going to put a rank on the DF1 based on the designation. So I just want that on the data scientist side, who is the rank one based upon the salary, on the full stack side, and on the HR side, who are there. So first I have to define a window. Import the window as well. Now I'm going to be partitioning by designation, because for each and every designation, I want the rank.
Okay.
And what would be the order by? It's the same concept in SQL. Can you tell me?
Salary.
Yes, salary, that too. And
Listening. Yeah.
this, yeah. So my window function has been defined. You see what's happening over here? For data scientists, this is the highest salary. So that's why it's rank 1. And then the rank 2. Full stack also same thing. Okay.
Hmm.
1, 2, 3. So if I have a record which is having the same, so do you know the difference between rank and dense rank?
Yeah, yeah. So if two entries have same
Right.
salary, then number is skipped.
Yes, yes. So it's the same thing over here. So I'm not using, so instead of rank, it should be putting like this. Okay. Otherwise, if I don't want any skip at all, in that case, I can use the row number as well.
Okay.
So this will give me the same result over here because there is no duplication of salary. So this is one thing. Now, let me show you one example of UDF. All right. So up until here, it's probably I have already described filter column, then with column, when the IT professional, this thing you understand, right? The case when column.
Yes, yes.
Okay. Now coming to a new thing that is UDF. So UDF is basically it's a user customized function. So when I was using the rank, dense rank, or over here the when with column, all these things are Spark inbuilt functions. Okay, like I have concat, I have other like explode. I will show you the explode. It's the same as the SQL one. But whenever there is a customized logic that I need, and the Spark SQL function doesn't provide me that, in that case I can write my own function, and then I can use it in my Spark SQL code. So over here, this format salary, so it's a Python function. It's a raw Python function. It has nothing to do with Spark. But I'm using this function over here as a Spark SQL function. So basically, that is the reason UDF is being defined. Okay, I'm coming to this function later, what it is doing. But if I talk about this one, so first of all, I have to use this format cell function in the UDF wrapper. Okay, in the UDF wrapper, what will happen? This lambda will be called upon for each and every column value. You remember when I was teaching you in Python in the very first session, lambda is a method or function that is being called upon for each and every element in the collection, be it list, be it set. So similarly, over here, it is the data frame column. So whatever data frame column series that I'm using, so if it is salary, then for each and every salary, this function should be applied. Right. So
Yeah.
that is why the lambda is being called upon. And this is just a placeholder. I can put X over here as well instead of underscore, but usually I prefer the underscore one, which looks much smooth. Okay. So for each and every element of the column value, this format cell function will be called upon. And then the return type will be the string type. Whatever the function is returning, that should be the string type. So this
Yeah.
is the UDF wrapper is doing, is basically converting into a UDF function. And then this UDF func, I'm calling upon in formatting my one of the column. That is, I'm creating one formatted salary, and I'm calling the UDF function and putting the column salary into my function. That is the UDF function. Okay. So what's happening if I state from here? So I am creating a new column, then I'm calling the UDF function upon the column salary. Now in the UDF function, what is happening? It is getting the lambda call and using the lambda call for each and every column value of the column salary. That is for 5,000, 40,000, whatever. It is calling the format salary function. That is the raw Python code, and um, the output or the return type will be the string type. Okay. So now coming, so this is how the UDF is called upon. All right. Now coming to what this function is actually doing. So if you see over here, this formatted salary is just giving me this comma portion, just making it like beautifying it, so to speak. Okay.
Hmm.
So I want it this way. So I know in the Spark SQL, there is no such function where I can put it like this customized logic. So I am writing this function. So first of all, the salary can be string as well, based upon the info schema while I read the file into a data frame. So I'm typecasting is into integer. I'm making sure that salary that is being read, it is typecasted into integer, because then I'm doing a comparison over here that it should be greater than 9,099. I mean, it should be at least more than 10,000 to format this into this format. Okay, so first typecasting the salary and making sure it is greater than 9999. Then this, then the logic is if it is greater than 10,000, then how it is formatting. Basically, after the, I mean, after the comma, 3 zeros will be left, right? Be it like 3,50,000 or be it like 25,000 or 40,000. After the comma, there will be 3 zeros. So I'm making sure that the comma index where the comma should be placed is from the size or from the rightmost size. Sorry, from the rightmost side. It should be like shifting to 3 digits or 3 places into left side from right to left. Okay. So that is how I'm basically evaluating the index. So length of the string salary, how it is? Length is the total size. So if it is 40,000, so it is 1435. Now, if I do 5 minus 3, then it is 2. So basically it is coming to 0, 1 and 2. Okay, let me just put it over here like this. So 40,000, right? 4000. Now this is the 0th index, this is the first index, this is the second index, this is the first index, third index, and this is the fourth index. Okay. Now the length of the salary is how much? 5, right? Okay. I am doing minus 3. If I do minus 3, it is equals to 2. Now if I talk about index, this is 0th index, this is first index, this is second index. Now this is where basically comma should be putting in. So before this 0, if I put the comma over here, so comma will be in second index, right? And then this is third index. So that is the index. So this is the index where I'm trying to put the comma in. So if I look at the comma index, is basically evaluating the from the right side is basically minus 3. So in which place the comma should be put in. Now returning it in the salary, what I'm doing. So this is string splicing. So this column means. So suppose if I give something like let me open a shell over here. So this is a string that has A, B, C, D. So if I say A, from 1 to I need 0, 1, 2, 3. So if I say 2, in that case, it is giving me B. Why it is giving me B? Because starts from the 0th index. This is the first index where B resides. And then from 1 is to 2. 2 means this is 2, right? In the second index, it is C. But whatever be the last one in the right bound, it should be, it gets excluded. So if I want C as well, in that case, I have to put 3. Okay, whenever you call the range function, you know that is the range function in Python, right? Where we put something like 1 to 10 or even sometimes only 10. So 1 to 10 means it will read from 1, 2, 3, 4, 5, 6, 10. But if I put only 10, in that case, it will read from 0, 1, 2, 3, 4, 5, 6, 10. But anyways, it will not go up to 10. So if I printed everything, so it will be 1 to 9 or 0 to 9. So similarly over here, so what happens is that whatever the outbound I'm keeping, that one doesn't comes in Python. So this 1, 3 would give me B and C. Okay, but if I want everything up until the third index, okay, up until the D, in that case, I can simply remove this one, and this will give me ABC. So this means I'm not specifying what is the inbound or what is the right bound. Fine. So that is why it's taking everything from the beginning. So if the opposite I want, so I want like everything from the say from first index, I want everything. In that case, A will be deducted and everything else will be highlighted, B, C, D. Okay, from first index, I'm calling upon everything. So similarly, over here, what's happening is that while I'm returning, I got the comma index, right? That is in the second index. So from first to up until the comma index, you return me the salary. With that, I'm adding the comma. So this is 0, 1, then comma in the second place. And after that, from comma index to whatever it's remaining. Okay, so that is from rest of the zeros. So this is up until comma index 40, then plus comma, then the rest comma index to last. Then it is giving me the last three zeros. Okay, so that's how basically it's returning the salary. And this is just an edge case. If my salary is suppose say less than 10,000, in that case, I won't be formatting. Like for this 5,000, it is only 5,000. There is no comma. Okay, so this is UTF and that's how it works. But in general scenario, it is recommended to not use any UDF at all, especially in Pyspark. Because the thing is, UDF is a raw Python code and Pyspark, as you know it, it runs on JVM. So Java and Python has like a 36 ka aakra. Okay. So whatever you write code in Python, JVM doesn't understand that. So what Spark will do, it will convert into a JVM understandable language, and then it will process it. So basically, there is a bit of time that is taken to process your raw Python code into a JVM understandable code. Then it will process the rest of the part. So that is the reason. Like if you're not like totally desperate, in that case, never try to use the UDF.
Yeah.
All right, so this is pretty much it, and I have covered in almost everything about Python Spark. The Spark one is totally done.
Okay.
So let me stop the recording.